to the Python version of verifying the hand calculations that were done in the example. So let's see. This is the numerical example that we're doing. Is we're looking at this one where you have a mover located at 20 minus 30. At time 0, it starts moving to destination minus 1050 at a speed of 30. And the three questions that we're interested in is, first of all, what is the velocity of the mover during the move? That was computed theoretically to be, minus 10 something and 28 something. When does the mover arrive at the destination? That turned out to be at time 2.8 something. And then what the mover's location was at time 2, which was before it actually reached its destination. And the way to check is we're going to instantiate a simplest mover, a simplest path mover manager, give it the destination as its one waypoint. We'll run it in verbose and check. We can check values 1 and 2. That is, for questions 1 and 2, we can do that. Now, how we can check location at time 2, that will take a little bit more work. If you were following the Java one, we're going to do pretty much the same thing. That is, just have a little, write a little class to fire a state change for the mover at that given time. So let's see how that goes. Let's create a new. Now for the Python ones, there's a Python file called mover.py, and that has the point in it as well as the simplest mover in the mover manager. So all of those are in there. But let's create another one. Let's call it check the mover, as we were doing with the Java one. And so what are we're going to need? We're going to be running it. So on the base, let's import the R event list, and we're going to need our simple state change dumper, and then from our mover, we need our simplest mover and our simplest path mover manager. All right. Oh, and also we're going to need our point. So let's start by our initial location is going to be a point at, what was it again? It was 20 minus 30. And our speed was 30. And as I kind of, this is sort of semi-optional, but I harangue my Java students with this, and maybe in Python it's a little different, but because it's more loosely typed. But even when there's, if I'm using something as a floating point, then I always put the dot on. So obviously it would be exactly the same if I left it off. The principle that I kind of harangue them with is programmer's intent. In other words, and for this example, it doesn't really matter, but in others, it kind of does sometimes. In other words, well, and it matters more in a strongly typed language. And interestingly enough, it's been a while since I've really paid a lot of attention to what's going on in Python. I noticed that they have things called type hints now. So it's like they're starting to realize that, hey, maybe this typing thing is not such a bad thing after all. Anyway, not that withstanding. The thing is that if you have, say, if you just had that, what was the intent? Was the intent that this be an integer or that this be some floating point number? If I leave that off, that question is ambiguous. So if I put the decimal point in, there's no ambiguity. It is absolutely clear that I mean a floating point value. So anyway, so let's instantiate our mover. And I think we give our initial location and the speed. And then as I harangue them as well, when you're developing this anything, I try not to write too much code before testing it. So here, all I'm doing is I'm instantiating one of these movers, and now have I instantiated it correctly? How do I know? I know it only if I run it and see that, okay, the initial location got in okay, and the speed got in okay. That's what I'm looking for. All right, so now let's do our other one. So let's, our path is going to be our destination, and our destination is minus 1050. So that's going to be our path, and then so we our simplest path mover manager, and I think okay, so I give, unfortunately I should have reversed those, but anyway, I said what the first argument is just says to run it immediately, and then before I take another step, I want to make sure that I've gotten that in, because this is actually easier to screw up. In fact, so I want to make sure I got the path in right, and that starting it on run is right. Okay, so I have that, and I want a simple state change dumper, and then I want both the mover, add state change listener, and our mover manager. We want a state change listener. All right, and then now remember that they have to listen to each other. See, this is the thing. So the mover listens to the mover manager. The mover manager listens to the mover. So how do I do that? I do that by add sim event listener. So there's the mover manager listening to the mover, and then the mover manager add that. And then now, let's run it in verbose mode. And we reset. And we start simulation. And what I'm looking for is I'm looking for the velocity to be at the right, and the end move event to be at 2.8 whatever. So let's run. Hopefully I did that right. And so let's see what we got here. So we have the run for the simplest mover. Okay, so that's setting us our state variables correctly. Our last stop location is our initial location. The velocity is 0. Our start move time is 0. We don't have a destination yet. And then the run for simplest path mover manager, the next index we initialize at -1. Why? Because that's kind of an off by one thing. We don't have a destination yet, but we've scheduled our next waypoint. And our next waypoint says our next index is now 0. Our destination is now, that's the right one. And now we're going to move to that. Okay, check. There's the move to. And then notice, because of the listening, that schedules the start move. And here's the first state. So at the start move event, we have our velocity of 10.534 to, so it's, I only did this up to 3 decimal places, but minus 10.534 to 28.090. So that, at least up to the decimal points that I have there, that checks. If I don't like that, I can actually, I could add a 4th decimal place, but okay, so we have that check there. And then when does the end move occur? 2.8480. Again, 2.8480, again up to 4 decimal places. Again, not exact, but we got a check there. Okay, so now how do we check the location at time 0? So we need another event at time 0. So how can we do that? Well, what we can do is just write a little local class here. So all right, so we have sort of, it will do the little if, what is it, main equals, it's if its name equals name main. I keep getting these confused. Then we're going to execute all these, and we have to indent them. Let's just make sure we didn't screw something up with that. Okay, so that that's all working. Okay, and so before that, let's the class called CheckMover. It should extend SimEntity base, and what it's going to do is it's going to have 2 arguments. First, we're going to have a time, and then a mover as its parameters, and then we need to invoke the super class constructor, and then and if we want to really be pedantic, time must be bigger than or equal to 0, but you gave me this one, so just to, and if we make it past that, we can sort of set them. So what do we do? All we need, now notice we have no state variables, and so we don't need a reset method, but we do need, we're going to schedule, let's do it a CheckMover event. At the given time, and what will that do? It will simply notify a state change, and we'll call it mover, and then mover current location. Remember, current location in the mover, let's just sort of see what that is about. That uses the equation of motion, that is this equation of motion, to determine where the thing is at any point in time. And so that is down here. So what we do is we have sort of the elapsed amount of time, and then the last location plus the velocity times the elapsed. We return it as a new point. Okay, so now what we can do is we simply CheckMover with our time, we can hard code 2.0, but give it our mover. And let's just make sure that got in there okay. And then let's, in order to print it, now notice that we could have put a print statement in here, but that would violate the principle that when it comes to these simulation components, the simulation components should never have a print statement in them. what they should do is, if there's something that you want, instead of the print, do a notify state change. And what you're notifying, I mean, it doesn't, even though it says mover is not a state, but the current location, in a way, is like a state change. So in other words, at time 2, the mover's state is where its current location is, even though current location is not a discrete event state. Okay, so what we're looking for here is that there's going to be this CheckMover event at time 2, hopefully, and at that time we can check to see whether or not the actual location of the mover is this -1 something and then 26 point something. Okay, so let's run that, and hopefully that worked. And okay, so there's our CheckMover event, and we see that our mover was located at -1067 26 180, and that's pretty much what it was. And if you want to make them exact, I think all we need to do is in our points 2 string here. Let's find that. Okay, so for some reason I had it with 3. Let's change that to 4, just to, and we see it's compare. Okay, -10,674, 26,1798. So they're, they actually kind of match out to that. Okay, so this is how it's done in Python. I will commit this, and you'll have a chance to, when you do a pull on the code, you'll have a chance to look at it. I will come back and comment it later. So that is that.